Hello my dear students, good afternoon. Previously we discussed about hydrogen spectrum in atomic structure. Afterwards we will discuss now Bohr's atomic model actually. Okay. So previously what we have atomic models, J.J. Thomson atomic model and Rutherford atomic model. In Rutherford atomic model, if you see, some drawbacks are there. What kind of drawbacks? If atom revolving around the nucleus continuously, that have to lose energy continuously, certainly that have to fall into the nucleus and atom should collapse, but atom is highly stable. That particular drawback was explained by Mr. Niels Bohr actually. So what are the important postulates? Important postulates in Bohr's atomic model. Let's see one by one. What he said, Mr. Bohr, first thing, according to Bohr, in atom, electron will around the nucleus. Electron will revolve around the nucleus with high speed in circular paths, which we call orbits or shells. So what is the first postulate? So atom consists of nucleus, everybody knows. Around nucleus there are circular paths like this. These are the circular paths. 1, 2 and 3 like this, and 4 if you want. Okay, so around nucleus these are the circular paths, and these circular paths denoted with a particular letter small n. Small n is called principal quantum number, which shows orbit number. Orbit number is equals to 1, then the shell is called K shell. Orbit number is 2, then the shell called L. Orbit number is 3 and shell called M shell. Okay, orbit number is 4, then that is called N shell. Okay, so this is the first shell, this is second, and this is third, and that's 4, like that. Understand? So if you want 1, this is 2, and this is 3, and this is 4, fourth shell. N is equals to 4, N shell. So what is the first postulate given by Niels Bohr? Around a nucleus, electrons will revolve with high speed in circular paths, which we call orbits or shells. Okay, those orbits or shells denoted with a small n, n called, what that n called? Principal quantum number. N gives that particular orbit number. Okay, and those shells I can represent with half like this. Okay, half shell. So first shell and the second, and this is third and fourth like this. Okay, and if you want fifth shell, as told now, these shells are nothing but energy levels. In hydrogen spectrum I told or not? This is the first energy level, this is second, this is third, this is fourth, this is fifth. So he given n is equals to what? 1, n is equals to what? 2, n is equals to what? 3, n is equals to 4, n is equals to 5. If n is equals to 1, the shell called K shell. N is equals to 2, L shell, M shell, N shell, okay, O shell, and so on like this, and so on like this. Okay, so first postulate over. Electrons are revolving in circular paths, which we call orbits or shells, and that is the first postulate. And the second postulate is electron while revolving in a particular orbit, there is no change in energy. There is no change in energy. Okay, but if electron jumps from one orbit to another orbit, then what happens? Energy changes. Actually, as this quantum number, this n value increases, energy increases in this way. This is a increasing order of energy. Energy increases in this manner. Means K shell is a lower energy shell, next L shell, next M shell, next N shell, next O shell. And next O, P, Q, R, S, like that. After O, what shell will come? Don't ask me. Alphabets. Starts from K. Why K? Actually, his Bohr's co-scientist, actually, his assistant, name starts with K. So from there he was given K, L, M, N, O, P, Q, and so on like that. Okay. So energy of orbits increases. And the second point, if electron revolves in same orbit, then no change in energy. That is the second postulate. What is the first postulate? Electron is revolving. Who is revolving in these circular paths? First I was given round, no, but that occupies more space. That's why I was erased and written this one, half part. Okay, electron is revolving in high speed in a circular paths which we call orbits or shells. The second point, second postulate, if electron revolves in same orbit, then there is no change in energy. And one more thing here I told, energy increases as shell number increases. Energy of orbit, what happens? Orbit energy, what happens? Increases. Orbit energy increases. This is a very, very important point. So K shell is more energetic or L shell? K is less energetic than L shell. L is less energetic than M shell. Like this. This is the order of energy. M shell, N shell, and so on like that. So what is the second postulate I was given? And the third one is very important. If electron jumps from lower energy level to higher energy level, then energy absorbs. At the same time, if electron jumps from higher energy level to lower energy level, then energy releases. That is our next point. What is our next point? If electron jumps from lower energy level to higher energy level, then energy, what happens? Energy absorbs. By whom? Energy absorbed by whom? Absorbed by electron. So electron, if jumping from lower to higher, suppose these all, see, here to here, or here to here, or here to here, or from anywhere, from here to here, or here to here, or here, here to here, or else from here to here. This all requires absorption or release? Absorption of energy. Energy required. Because electron jumping from lower to higher, actually. Electron 1 to 2 or 2 to 3, 3 to 4. Understanding what is 3 to 4? Third shell to fourth shell, or fourth shell to fifth shell. Suppose electron jumping from lower energy level to higher energy level, it requires energy. Getting what I am saying? Just like our motion. Suppose I wanted to jump this much of height wall, then I have to use some energy because I am going from lower level to higher level. Then I need some energy, I have to use some energy. Suppose I wanted to jump from the wall to ground, then I have no need to use. If I remove my legs enough, I will fall down. Getting? So from higher level to lower level, if electron coming, then no need of energy. Okay? So 1, 2, 3, 4, 5, those are the orbit numbers. If electron jumping from lower to higher, energy absorbs. If electron jumps from like this, higher to lower, like this, understand it? Like this, or else like this. These all requires, what requires energy? No. Energy release. When energy release? If electron jumps from higher energy level to lower energy level. This only the explanation which was the drawback in Rutherford atomic model. Suppose that only, you remember in Rutherford, what I said, if electron revolves in an orbit continuously, that have to lose energy continuously. So that is not happening actually. What happening? Electron is jumping from lower to higher and higher to lower. So particular total energy of a particular electron in a particular atom will be constant. Okay, so what is our next point? Total energy remains constant. Understood? And that energy is always equal to h nu. This we discussed in Planck quantum theory. Do you remember? Energy always emits or absorbs in the form of h nu. One h nu is called one photon, 2 h nu, 2 photons, 3 h nu, 3 photons, like that I was given in previous. Do you remember? So till now what we discussed, if you see one by one, electron is revolving in circular paths which we call orbits or shells with high speed. First point. And the second point is, if electrons revolves in the same orbit, then there is no change in energy. This is the increasing order of energy. If electron jumps from lower orbit to any lower to higher, for third, second is the lower. For fifth, fourth is the lower. For third, fourth is the higher orbit, higher energy orbit. Understanding? So, if electron jumping from lower orbit to higher orbit, energy absorbs. If electron jumps from higher to lower, then energy releases. Getting what I am saying? So these only I was given here. And total energy of electron in a particular atom is always constant. Whose energy? Total energy of electron in a particular orbit is always constant. Getting what I am saying? So energy of nth orbit, actually total energy is always constant. Got it? So that total energy is always in the form of h nu. Actually not 1 h nu. So you can say energy is always some n h nu. N means number of photons. 1 h nu, 2 h nu. 2 photons means 2 into h nu. 3 photons means 3 into h nu. Like that I told or not? So these are the important postulates, and one more postulate is there, that is the last and final in Bohr's atomic model. So hope you written all these things. Okay, so you have to draw this diagram, and this is very important for us. Okay, so next we have to discuss about the last and final point in this Bohr's atomic model. Okay, and few more I was given already, that also I'll explain here. Okay, what is that? Fifth one. Electron, when revolving in a certain orbit, in a particular orbit, it has angular momentum. Okay, so for revolving electron, angular momentum he was given. Angular momentum. So angular momentum, actually momentum means, I think mass into velocity. Angular momentum for a particular revolving electron we called as MVR. What is angular momentum? Mass into velocity into radius. That is called angular momentum. So angular momentum for a revolving electron he was given. Okay. So what he given? He said angular momentum of electron is equal to integral multiple of h by 2 pi. H by 2 pi. What he said? So according to Mr. Bohr, what is that? Angular momentum. Angular momentum means what I said? MVR is integral multiple of h nu. Integral multiple of h nu he was given. For revolving electron, what he was given? Angular momentum given. What is angular momentum? Momentum means, mass into velocity. For a circular path, you will have angular momentum. So electron is revolving in a circular orbit that have a radius, because this is an electron revolving path. Suppose here electron is there and here to here, this is called radius. Correct? Radius means from nucleus to outermost shell actually. Okay, nucleus, outermost orbit or shell. So it has a mass, electron while revolving, it has a mass and it has a velocity because it is revolving with certain speed. So angular momentum MVR is integral multiple of h by 2 pi. Sorry, h nu I was given? No, that's not correct. So what you can write therefore, angular momentum MVR is equal. Integral multiple means some number nh by 2 pi. Integral multiple of h by 2 pi means what is the meaning? Some integral multiples means 1h by 2 pi, 2h by 2 pi, 3h by 2 pi, 4h by 2 pi, like that. So here I given now n is equals to 1, n is equals to 1. What shell that is? K shell, I told you already. N is equals to 2, that is L shell, I told. N is equals to 3, M shell. N is equals to 4, N shell, like that. What is the, suppose example I am giving you here. What is the angular momentum of electron present in M shell? Present in what shell? M shell. If they ask, M shell means what is the n value here? 3. Therefore, what you can say, angular momentum MVR is equals to 3h by 2 pi. I can write now. Because electron present in M shell. Because n is equal to 3 for what shell? M shell. So simply I can write 1.5 h by pi. 3 by 2 is nothing but 1.5 or not. So MVR is equals to 1.5 h by 2 by example I was given here. Got it clearly? So angular momentum I was given. I was not given actually. Angular momentum of electron, revolving electron, given by Bohr. What is the angular momentum he said? If electron revolving in a certain orbit, the angular momentum MVR is integral multiple of h by 2 pi. Integral multiple means nh by 2 pi, where n is equal to, what is n here? Shell number 1, 2, 3, 4, like that. Do you remember? N values just previously I was given. What is n? Don't ask me. Shell number. What is that? Small n, principal quantum number, or else shell number. Shell number 1, K shell. Shell number 2, L shell, like that. So these are the important postulates. All postulates you have to write. These are very, very important. Okay. And one more important thing here only I will give you now. So these shells consist of actually orbitals, degenerating orbitals. Okay. So electrons as like building. Building is a atom. In building, first floor, second floor, third floor are shells. First floor, K shell. Second floor, L shell. In those, you will have rooms. No? First floor have 4 rooms. These are called subshells. Those subshells we have some again classification, degenerating orbitals. Okay. So you have one formula I will give you here only. Number of degenerating orbitals present in a shell, formula n square. What is the formula, sir? N square here. Number of degenerating orbitals present in a shell. Suppose number of degenerating orbitals orbitals in L shell, how many means n square. L shell means what is the n value? 2. Just now I was given no. N is equals to 1 K shell, n is equals to 2 L shell. Okay. So number of degenerating orbitals in L shell, if anybody asks, just simply 2 square. So 4 degenerating orbitals are present. We will understand in quantum numbers again. Of course, I was given quantum numbers before, but few was not joined at that time. Okay, so definitely I'll give you full information of all these things. So you have no need to worry. You have to do only one thing. Just follow my class. Believe me, I will give you best. Okay. So number of degenerating orbitals in L shell is equal to n square formula. So what is n value for L shell? 2. So 2 square 4. Okay. In same manner, you have one more, that is number of electrons present in a shell. In shell, how many electrons you have? Number of electrons present in a shell, not a shell, in a shell. Okay. Oh, then formula 2n square. Number of electrons present in a shell. What is the formula? 2n square. What is n value? I am writing again. 1, 2, 3, 4, 5, 6 and so on like that. So K shell means n is equals to 1, L, M, N, O, P like that. N is equals to 1, K shell. N is equals to 2, L shell. N is equals to 3, M shell. Suppose number of electrons present in a third shell, in third shell, not in a third shell, in third shell, how many electrons are present? So 2 into 3 square, or M shell they will ask you. Instead of giving shell number, they will give you number of electrons present. Number of electrons present in n shell, how many means just what asking? N shell. N shell means what is the n value I told? 4. N is equals to 2. So 2 into 4 square. That means 32 electrons will be present in n shell. Getting what I am saying? So in that way, first shell 2 into 1 square, 2 electrons. Okay, electrons here. 2 into 2 square. Okay, like that. In M shell, like that. How many electrons present in a shell? We can have like this by using Bohr's atomic model. So Bohr's postulates, if you see, all we discussed, these two also very important. Write down everyone. Number of degenerating orbitals. About degenerating orbitals, I will give you very clearly in quantum numbers. Don't worry. Okay. For the remaining students, few students know this already. Don't worry. Okay. Remaining also can understand. Now, what we discussed here means electron revolves in a circular orbits, which we call shells or orbits, and electron if revolving in a particular orbit, energy remains same. Electron jumps from lower energy to higher energetic orbit, energy absorbing, higher to lower energy releasing. If electron revolving in a certain orbit, energy remains constant, and as you are going away from nucleus, energy of orbit increases. You written those points. As you are going away from nucleus, energy of orbit, what's happening? Increasing. K shell is more energetic or L shell? L shell is more energetic. So as you are going away from nucleus, energy, what's happening? Energy increases. Energy, what happened? Increased. Okay. So these all are very, very important. So now we will discuss one most important concept, that is radius. Radius of nth orbit. If electron is revolving in a certain orbit like this, who is revolving? Electron is revolving in a certain orbit. This is called actually radius. So electron is revolving in this particular orbit. So when electron is revolving, you have some radius from this nucleus to this particular shell. This radius to calculate, we will derive one formula now. Getting what I am saying? Okay. So what we will do now, we will derive one formula to calculate radius when electron revolving in a certain orbit. That we will do right now. Okay. By using two things. When electron is revolving in certain orbit, it has two types of forces. One is attractive forces and one is repulsive forces. This arrow towards nucleus is called attractive forces. Seriously, you only tell me, if electron is revolving, if it is not having repulsive forces, if it is having only attractive forces, then electron will fall into the nucleus or not. But that's not happening. That means revolving electron has two forces. One is attractive force and one is repulsive force. This one is red color, is attractive force. Attractive force is called centripetal force. Centripetal force. And this blue color is repulsive force. Repulsive force is called centrifugal force actually. Centripetal force and centrifugal force. Okay, so those two formulas you have to remember. I will give you right now. So what I told you, for revolving electron, if electron is revolving around the nucleus, that's having two types of forces. One is attractive forces, one is repulsive forces. Attractive forces is called centripetal force and repulsive forces centrifugal forces. Now I'll give you formula for centripetal forces. If for revolving electron, the centripetal force of attraction, centripetal force of attraction is equals to minus ZE square by R square. Okay, centripetal CP, pizza, like that you can remember. Okay, centripetal force of attraction is equals to minus ZE square by R square. This is the equation 1. Got it? At the same time, for revolving electron, the centrifugal force of repulsions is minus mv square by R minus, so CF centrifugal minus mv square by R. Like kinetic energy, how you remember kinetic energy of mv square? Like that you have to know these two formulas. These are completely new for you. Okay, centripetal forces formula minus ZE square by R square, and the centrifugal forces formula minus mv square by R. So this is the second one actually. Okay, this is equation 2. Got it clearly? So now if electron revolves in a particular orbit, if electron revolving in a particular orbit, then these two forces will become same or not? Tell me. You only tell me. Electron position is fixed. To know the radius, I have to assume that yes, electron present in a particular orbit. Suppose I have one repulsive forces, I have one attractive forces from both left and right side like this. Now, if my position have to be fixed, means these repulsive forces must be equal to these attractive forces. Then only my position will be fixed or not, otherwise my orbit number will change. Suppose repulsive force is more, I will go this side. Attractive forces are more, I will go this side. So electron, if revolving in certain orbit, then Cp is equal to Cf. When Cp is equal to Cf, sir? When the centripetal force is equal to centrifugal force, if electron revolves in a particular orbit, then what I can say, equation 1 is equal to equation 2. Okay, so can I write this? You draw this one please, okay, by pausing video. So I will continue here. Okay sir, so equation 1 is equal to equation 2 means what is the meaning of that? Centripetal force is equal to centrifugal force. That means here I can say minus mv square by r is equal to minus ze square by r square. Can I write centrifugal forces? Of course I written ulta. So equation 2 I written here, minus mv square by r is equal to minus ze square by r square. These forces are called, what this force is called? This force is called centripetal force and this force is called centrifugal force. So this negative and negative will cancel and r square will cancel. So mv square is equal to ze square by r. Correct? So please remember this. This is very important. So after equalizing this centripetal force and centrifugal force, you have mv square is equal to ze square by r. And velocity we don't want in this term because you are finding radius. Okay, so instead of this velocity, actually v is velocity actually. M means mass, r means radius. Do you know what is z? I will write everything, don't worry. Okay, so z is atomic number. You know all this. This is charge of electron actually. R means radius, M means mass of electron. I will give everything later on, don't worry right now. So we know just from Bohr's atomic model, according to Niels Bohr, what you know? Angular momentum. Angular momentum. Angular momentum. MVR is equal to NH by 2 pi, right? Correct? So what is V? Therefore V, this V is equal to small v, okay? This V is equal to NH by 2 pi into MR. So V is N square H square by 4 pi square M square R square. So this is V square you have. So this V is N, this MR coming this side. So V is equal to NH by 2 pi MR. Now V square is equal to, what is this? V square. V square is equal to N square H square by 2 square, 4 pi square M square R square. Suppose now this is equation 3 now. Okay, this is equation 4 now. Now what I will do, just write down, okay, follow me and write down. This also write down now and I will continue from here to here now. Okay, I will erase this. Writing sir? Okay. So now what I will do, I will substitute this here. Okay, substitute equation 4 in equation 3. Then what I will have, instead of V square M into, instead of V square I will have this N square H square by 4 pi square M square R square is equals to ZE square by R. Correct? So what will cancel? Let's see. This is everything you are able to see what I written. So I'll write somewhat big letters if you want. So what I get, M into, instead of V square, this is V square, I will write this. Okay, n square h square by this 4 pi square m square r square is equal to ze square by r. Correct? What will cancel? This m and square will cancel, and this square and r will cancel. So radius remains. So what is radius now? So simply n square h square by 4 pi square m, okay, is equal to r is equals to ze square remains. What remains here? Ze square remains. So now radius comes that side. So n square h square by 4 pi square m ze square is equal to radius. This is the radius formula. Okay, so I will write the same like this now. What I will write? Okay, this r is there, no? This r goes that side. So r I will write here. So remaining is what? N square h square by 4 pi square m. This ze square term coming in the denominator. So ze square. Got it clearly? So radius formula you have. What is the radius formula now? Therefore, radius formula you have right now. Tell me, sir, what is radius formula? R is equal to n square h square by 4 pi square m ze square. What is V here? V is velocity of electron actually. You know, already I told you, in angular momentum this is mass, this is velocity, this is radius. I told you already. nh by 2 pi, h is Planck constant. You know all these things previously. H you know, no, Planck constant here. So every term I will explain here. Okay, so hope you written all this. So radius formula you have, and this centrifugal force, centripetal force equalized if electron revolving in a certain orbit. Then I got mv square is equal to ze square by r, and according to Bohr angular momentum, mvr is equals to nh by 2 pi. So v is equals to nh by 2 pi mr I got in the denominator. Okay, so v square is equal to, I was square both sides. Okay, so v square is equals to n square h square by 4 pi square m square r square. This v square I was substituted here, and after substitution I was written like this, and I was simplified radius formula like this: n square h square by 4 pi square m ze square. So you must write all those things, everyone, please. So this is a very important radius formula. Okay, so one by one I will write here. N is what? Shell number. N value, you know this already. So K, L, M, N, like that. So in number they will say, suppose 1 and 2 and 3, 4, like that. They said radius of electron which is present in K shell means N value 1 we have to take. Radius of electron which is present in M shell means N value, which shell I said? M shell, means 3 we have to take. L shell 2 we have to take. So N is the number 1, 2, 3, 4, like that. Don't substitute K, L, M, N. Okay, substitute N value. In this formula, what we have to substitute instead of N while solving radius? N value. N is equals to 1, 2, 3, 4. Those numbers are there, no? Those we have to substitute. And H, we know this Planck constant 6.625 into 10 power minus 34 joules or else, like that, you know already. And pi value, you know, 3.414 pi value. And M means mass of electron. Suppose this is in joules, mass of electron should be in kg. You remember mass of electron? No, 9.1 into 10 power minus 31 kg. That. Here Z is atomic number. Z is what? Atomic number. And E is charge of electron. Everything I written. What is R? Don't ask me. That only you are calculating. R means radius. N 1, 2, 3, 4, H Planck constant, pi mass Z. Sir, can we use this complicated formula for solving numericals? No. If you substitute these, of course N and Z is not certain, they are not fixed, because N value depends on shell. For what shell they are asking radius, we don't know. At the same time, for what atom they are asking, we don't know. Except this N and Z, you can substitute this H value, pi value, M value and charge of electron, then you will get radius 0.529 into n square by this n square you cannot substitute, and this Z value you cannot substitute. After substituting H value, pi value, mass of electron, charge of electron, do you remember? Minus 1.602 into 10 power minus 19 coulombs, like that. Do you remember that one? Okay, by Z. This is in angstroms actually. You simplify. Centimeters means 10 power minus 8 centimeter you will get. If you want this in 10 power minus 8 centimeter you will get. If you substitute radius, if you want in, but not centimeter means in ergs you have to substitute H value, mass of electrons in grams, charge of electron in ES you have to substitute. If you substitute, you will get radius formula. Don't worry, and no need to check by substituting all these things. Pakka, you will get this formula only after substituting H, pi, M and E. Those values you remember, simply H value, pi value, mass of electron and charge of electron. So finally you have a radius formula. What is the radius formula? 0.529 into n square by Z into 10 power minus 8 centimeter. Otherwise you will have a radius formula like this. Understood? Simplified formulas are this one. R is equals to what I said, 0.529 into n square by Z. Because for solving numericals, we cannot use that formula. Radius is equals to n square, h square by 4 pi square, mze square means when you will substitute all those things. To solve that one, you will take much more time. So that's why simplified formula this is. Okay. So into 10 power minus 8 centimeter. Okay. And R is equals to 0.529 into n square by Z angstroms. You tell me nanometers and picometer if you want. You can do that also. Because everything you know. 1 angstrom is 10 power minus 8 centimeter. 1 nanometer is 10 power minus 7 centimeter. So if you want in nanometer, I can convert now by using this. Suppose options given in nanometers. Sir, angstrom you given, but nanometer you was not given, no sir, formula. You can take now like this. 1 nanometer is or 1 angstrom is 10 power minus 8 centimeter. That means 1 angstrom is 10 power minus 7 centimeter into 10 power minus 1 centimeter. Correct? So 1 into 10 power minus 1. Okay, 10 power minus 7 centimeter is nothing but 1 angstrom is equals to 10 power minus 1 nanometers. Therefore 1 nanometer is equals to 10 angstrom. So instead of angstrom, I can use this one. 1 angstrom is 10 power minus 1 nanometer, no? So if you want in nanometer, into 10 power minus 1, that's it. That means 0.0529 into n square by Z you will get. Getting what I am saying? So I'm just giving you the conversions here. So these are very, very important. Note down all these formulas. So today we discussed two concepts. One is Bohr's atomic model and radius of nth orbit. Whose radius? When electron revolves, you are finding radius for a certain orbit. What is the final formula? Please remember and note it down. Thank you very much.